So you want to learn about Schrödinger's cat. While this wasn't a real experiment, it was meant to prove a point. Schrödinger didn't agree with the idea of a quantum particle existing in all its possible states at once, so he wanted to show his disagreement by using something simple, a cat. To understand Schrödinger's thought experiment, you must first understand superpositions. Superpositions state quantum systems like atoms, molecules, and electrons can exist in multiple places at once until it is observed and collapses into one result. Now stay with me here. In quantum mechanics, objects don't have definite positions or momenta. Instead, they have a probability of possessing specific positions when they interact with other entities. These probabilities are represented by the wave function psi, a mathematical expression dependent on space and time. By inputting coordinates into the wave function, we can determine the likelihood of locating a quantum object at a certain position and time. Schrödinger's equation connects the wavelength representing presence likelihood with the Hamiltonian representing total energy. It shows that the rate of change of an object's wave function is directly related to its total energy at any given moment. Now on to the actual experiment. Schrödinger's cat consists of a box, a cat in the box, and a mechanism that has a 50-50 chance of killing the cat. The idea is that before we go to check the box to see if the cat has died, the cat exists in a superposition, meaning that the cat is both dead and alive at the same time. It's only until we go to observe the outcome that the superposition collapses and chooses one of the possibilities, which is either the cat dies or remains the same. However, if we have two different cats in two different boxes, they become entangled in a superposition state, meaning that one cat will definitely die and one will definitely live. Quantum entanglement is when particles become linked so that the state of one instantly affects the other because they share a mutual quantum state. So measuring one particle determines the state of the other, even if they are far apart. So why is this relevant? MRI technology, PET scans, solar cells, GPS, and even the device you're watching this on would not exist without the science behind quantum mechanics. That's a lot of achievements for one cat.